Okay, ladies and gentlemen, this is section 5.1, part 3. This polynomial function is ugly. F of x equals the opposite of 0.064x cubed plus 0.56x squared plus 2.9x plus 61. Now, the words are telling you what it measures. This models the ocean temperature in degrees Fahrenheit off the coast of Naples, Florida. In this formula, x equals 1 corresponds to January, x equals 2 to February, and so on. So in other words, what you're putting into this problem is the digit that corresponds to the month, and what's coming out of this function is the ocean temperature, the average ocean temperature for that month. So when you see a problem like that, if I didn't explain to you what this function was, if I didn't tell you what input and output meant, it'd be a pretty useless function. So the wording in the problem is not there to intimidate. The wording in the problem is there to let you know what the input means and what the output means. And for those of you especially that are going on into college algebra, when you're working with a function, the very first thing you should ask yourself is there a meaning to the input and is there a meaning to the output? Because in a model problem, the answer is yes, there is, and you need to know what it is. Okay, part A. Explain why f of 0 makes no sense for this model. Well, if 0 is the input, you're trying to put in month 0, and I hope we all know there's no month 0, so that's kind of, rhetorical. All right, part B. What is the average ocean temperature in March? Well, obviously March corresponds to month 3. They're just telling me to replace x with 3 and plug it into the function, so I find f of 3. I plug into that ugly function the opposite of 0.064 in parens 3 cubed plus 0.56 in parens 3 squared plus 2.9 in parens 3 plus 61. Use your scientific calculator, and an exact answer is 73.012 degrees Fahrenheit, but that's a little ridiculous. When did you ever hear that on the radio? It's 73.012 degrees outside. That's a little odd. So what I'm going to do is put approximately 73 degrees, and there we go on that problem. Now, question or part C of this problem. Use the graph that I've given you to estimate when the maximum ocean temperature occurs and what the maximum is. Now, I drew the graph for you on my graphing calculator and I downloaded it into these lesson plan notes. So you're not going to have to worry about graphing something this ugly. Don't worry about that. Worry about knowing how to read it. When I ask you where the maximum of a graph is, what does maximum mean? It means the largest output. And that is going to occur at the tippy top of the graph. The very top of the graph is where the largest y value is going to be. So if I go to the very top of this graph and kind of play king of the mountain, and I read across to the y-axis, it looks like I'm pretty close to 88 degrees. Now again, it's hard to read from a graph with any degree of accuracy, so that's why I put approximately 88 degrees and not equals. The answer's not exact, but it's good enough for government work. Okay? All right, part D. Explain why f of 14 makes no sense. I don't know why I asked that again. I've already reiterated that, but there is no month 14. And the final part, what is the domain of this model? Okay, let's talk about what domain means. If I just said to you, give me a definition of domain, you're talking about what goes into a function. And if you ever forget that, by the way, a little mnemonic device to remember that, look at the word domain, D-O-M-A-I-N. The very last 2 letters of that word are I-N, in, okay? Domain is what goes in. So when I say f of 1, 1 is part of the domain. When I say f of 2, 2 is part of the domain. And of course, what would the domain be of this model? It would be your first 12 whole numbers. We're not going to count 0, obviously, but so I've written the domain out for you as 1, 2, 3, all the way up to 12. not all the numbers in between, because that doesn't make a lot of sense. You're just putting the month into the model.